Have you ever pondered why a steel ship can float on water, or why a helium balloon rises into the air? What makes these phenomena possible is the fascinating world of fluid dynamics. Fluids, substances that can flow and take the shape of their containers, include both liquids and gases. Today we will delve into the two fundamental types of fluids, static and dynamic. Static fluids are those that are either at rest or moving at a constant velocity. This state allows for no shearing forces between particles. The key principles associated with static fluids include density, pressure, hydrostatic pressure, Pascal's principle, and Archimedes' principle. Density, represented by the Greek letter rho, is the mass of the fluid divided by its volume. Pressure is the force applied per unit area, and hydrostatic pressure is the pressure exerted by a fluid at equilibrium due to the force of gravity. It's calculated as the product of the fluid's density, gravitational acceleration, and the depth of the point from the fluid's surface. Pascal's principle states that a change in pressure at any point in an enclosed fluid is transmitted undiminished to all points in the fluid. And Archimedes' principle tells us that the upward buoyant force on an object submerged in a fluid is equal to the weight of the fluid displaced by the object. On the other hand, dynamic fluids are those in motion, with varying velocities leading to shear forces between particles. Key concepts associated with dynamic fluids include discharge or flow rate, the continuity equation, and Bernoulli's principle. The flow rate, or discharge, is the volume of fluid passing a point per unit time. It is calculated as the product of the cross-sectional area of the flow and the flow velocity. The continuity equation states that the product of the cross-sectional area and the flow velocity remains constant from point to point in a pipe. Bernoulli's principle is a statement of the conservation of energy principle for flowing fluids. It states that the sum of the pressure energy, kinetic energy, and potential energy per unit volume remains constant in an incompressible, steady flow. In summary, the study of fluids, both static and dynamic, involves understanding the behavior and interaction of liquids and gases. With principles like Pascal's and Bernoulli's, we can explain phenomena like the buoyancy of ships and the flight of airplanes. By understanding hydrostatic pressure, we can predict the behavior of dams and submarines. And with the continuity equation, we can design efficient piping systems. So the next time you see a ship sailing, a balloon rising, or even just opening a tap, remember, the principles of fluid dynamics are at play, making our daily lives possible and our world fascinating.